Somewhere in the quiet dark, a star has finished burning. What remains is small enough to rest beside the earth, yet it still carries close to the whole weight of the Sunday tonight. We drift toward one of these fading embers, a white dwarf, and we follow its atoms all the way down, into a place where the gentle rules you learned about matter quietly come undone. Stay close and let your breathing slow. If these slow journeys help you, rest. A like and a soft subscribe. Help others find this quiet corner of the night. And before we begin, I find myself wondering where you are listening from and what the hour is, where you are right now. Let us begin not with the ending, but with a fire that has burned for a very long time. Picture a star much like our own sun, a slow, steady warmth hanging in the dark. For billions of years, it has been doing one quiet thing over and over, deep in its core, far below anything we could ever see. It has been taking the lightest substance in the universe, hydrogen, and pressing it together into something slightly heavier, helium. Each time it does this, a small whisper of energy is released, and the sum of all those whispers across the whole core becomes the light we know, the light that crosses empty space and lands softly on sleeping worlds. This is the bargain that keeps a star alive. Gravity is forever pulling the star inward, trying to gather all that gas into a smaller and smaller ball. And the fire in the core is forever pushing outward, holding the gravity at bay. For most of a star's long life, these two forces are perfectly matched, a balance so gentle and so patient that the star barely seems to change at all. It simply shines. But fire needs fuel, and even a star has only so much. Slowly, across an immensity of time that makes our own lives feel like a single held breath, the hydrogen in the core begins to run low. The fire does not go out all at once. It changes. The core, no longer pushing back as strongly, settles inward a little, and as it settles, it grows hotter, and the new heat lets the star begin to burn the helium it once made, fusing it into carbon and oxygen. The outer layers of the star, sensing this shift far below, respond in the strangest way. They swell. The star grows vast. It becomes a red giant, swollen and cooler at its surface, glowing a deep ember color, large enough that if it stood where our sun stands, it might reach out toward the inner planets and swallow them. This is not a violent thing. It is slow, almost tender, a great soft exhalation that lasts for many millions of years. The star is breathing out, and here is the gentle truth at the center of tonight. A star like the sun is not heavy enough to keep this going forever. It cannot reach the temperatures needed to burn carbon and oxygen into anything heavier. So once the helium is mostly spent, the fire in the core has nowhere left to go. The great swollen outer layers, only loosely held now, begin to drift away. They do not explode. They leave the way mist leaves a valley at dawn. Layer after layer floats outward into space, lit from within by the still glowing core, until the dying star is wrapped in a shell of softly shining gas. We have given these shells a misleading old name. We call them planetary nebulae, though they have nothing to do with planets at all. They are among the most beautiful objects in the entire sky, rings and bubbles and butterfly wings of colored light. The cast-off breath of a star spread thin across the dark, and in the very center of that fading glow, something is left behind. The core, the part that did all the burning. It is no longer making fire. It has nothing left to fuse, but it is still there, still holding nearly all the heaviness the star ever had. A dense ball of carbon and oxygen ash, glowing white hot, simply because it has not yet had time to cool. This is the thing we have come to visit tonight. This is the white dwarf, the ember left behind. Sit with that word for a moment. Ember. A coal pulled from a fire that has gone out, still warm in the hand, no longer burning yet still carrying the memory of heat. That is what a white dwarf is. It is the still warm coal of a star that has finished its life, set down gently in the dark, beginning the longest slow cooling in all of nature. When the star first becomes a white dwarf, it is astonishingly hot, its surface far hotter than the sun we know, hot enough to shine a brilliant blue-white, but there is no fire underneath anymore. There is no fuel. So from that first moment, the white dwarf can only do one thing. It can fade. It will give up its stored heat to the cold of space, slowly, patiently, dimming and reddening across an expanse of time so long that the universe itself is not yet old enough to have seen the end of it. We will return to that long fading later, near the close of our journey, when it is time to rest. For now it is enough to know that the ember has been set down and that it will glow for a very long while. Now, here is where the wonder begins to gather. You might imagine, hearing all this, that a white dwarf is simply a small star, a leftover, a faint thing of no special interest. But that is not so. Something has happened to this object that has happened nowhere else in your experience, nothing you have ever touched or seen or held. The matter inside it has been changed. When the fire went out, the bargain that held the star open was broken. Gravity, which had been so patiently balanced for billions of years, suddenly had nothing pushing back against it. And so it did what gravity always does when nothing stops it. It pulled the core inward, squeezing it smaller and smaller, packing all that carbon and oxygen into a tighter and tighter space. The core, which had been spread across a region larger than many planets, collapsed down until it was no bigger than the Earth. Let that comparison settle gently, because we will return to it again, turning it over like a smooth stone. Nearly the entire mass of a star, very close to the mass of our sun, gathered into a ball no larger than our own small world. The sun could hold more than 1,000,000 Earths inside it. And now all of that, very nearly all of it, has been pressed into a single Earth-sized sphere. To squeeze matter that tightly, something inside it had to give way. And what gave way was the atom itself, the very building block we think of as the smallest unbreakable piece of ordinary things. Inside the white dwarf, the atoms are no longer arranged. Way atoms are arranged in you, in the air, in the ground, in any stone you have ever picked up. They have been crushed. Their gentle structure, the structure that gives matter its softness and its solidity and its color and its chemistry, has been pressed beyond recognition. That is the promise of our journey tonight. and I will keep it slowly. We are going to travel down into this ember, past its faint white glow, through its still warm outer skin, and into the strange dense heart of it, to see exactly what becomes of matter when gravity squeezes it harder than anything on Earth ever could. We will not rush. We will take each idea one at a time, the way you might turn the pages of a book by candlelight, letting each one rest before the next. But before we go down, let us simply hold the object in our minds for a little while, the way you might hold a small warm stone before sleep. It is round, because gravity makes all large things round, pulling them in equally from every side until they settle into a sphere. It is white for now, because it is hot, though its whiteness will fade through yellow and orange and red across the ages. It is small, smaller than you would ever expect a star's remains to be, a thing you could lay across the face of the earth like a coin upon a plate. And it is quiet. There is no roaring fusion. In it, no churning, no violence. It simply sits in the dark and shines with borrowed warmth and waits. There are many of these embers scattered through the galaxy. They are, in fact, one of the most common endings a star can have. The great majority of all the stars that have ever lived, including our own sun when its time finally comes, are destined to end exactly this way. Not in a grand explosion, but in this slow, soft settling into a white dwarf. When you look up at the night sky, you cannot see them with your eyes, for they are too faint and too small. But they are there, uncountable, drifting among the brighter living. Stars, each one a coal from a fire that burned for ages and then quietly stopped. The nearest of them is a faint companion to Sirius, the brightest star in our night sky. Sirius shines so brilliantly that for thousands of years no one suspected anything beside it. But there is a second star there, circling Sirius in a slow waltz, a white dwarf so dim it was only discovered because its gravity tugged its bright companion ever so slightly off course. We call it the pup, the small dog beside the great dog star. It is about the size of the Earth, and it carries close to the mass of the Sun, and it is one of the closest examples we have of the thing we are journeying into tonight. When astronomers first measured the pup and understood what it must be, they did not believe it. The numbers seemed impossible. A piece of matter that dense could not exist, they thought. Not under any rules anyone knew. A single small spoonful of it would have to weigh more than they could imagine. There had to be a mistake. And yet, the measurements held. The star was real, the density was real, which meant that somewhere in the laws of nature there had to be a rule no one had yet understood. A rule that allowed matter to be squeezed this far and then somehow hold. That missing rule is the secret at the heart of our story, and we will arrive at it gently, in its own time, several steps from now. It is one of the strangest and most beautiful ideas in all of physics, and it turns out to be the very thing that keeps these dead stars from collapsing into nothing. For tonight, let this be enough. A star has lived a long and ordinary life. It has breathed out its outer layers into a shell of colored light, and in the center it has left an ember, small and warm and impossibly dense, a ball the size of a world holding the weight of a sun. Inside that ember matter has been changed into something we would not recognize, and we are going to go and see it. Let your shoulders drop a little as we begin to descend. Let the weight of the day loosen from them, the way the star loosened its outer layers, softly, with no effort, simply letting go of what it no longer needs to hold. There is nothing here that asks anything of you. There is only a quiet object in the dark, and a long, gentle path down into it, and all the time in the world to follow that path together. We will go slowly, we will go carefully, and by the end we will have seen, with our own imaginations, a place where the atom comes apart, where the rules soften, and where matter rests in a form that exists nowhere on Earth, only here, only in the still warm hearts of the stars that have finished burning. Breathe in slowly, breathe out slower still, and let us begin to fall gently toward the ember. Let us pause here before we go down and simply consider how strange it is that such a thing exists at all. For most of human history, no one imagined that a star could end this way. The stars seemed eternal, fixed points of light that had always shone and always would. It took a long, slow gathering of understanding across many lifetimes to realize that the stars are born and live and die, and that ours, the sun that warms our days, is no exception. It too is burning through its fuel, patiently, steadily. It too will one day swell and shed its layers and leave behind a small white ember. That is not a sad thought when you hold it gently. It is simply the shape of a star's life, the long, slow arc from gathering cloud to fading coal. And the white dwarf is the quiet, resting place at the end of that arc. Consider, too, how long the road has been for the matter we are about to visit. The carbon and oxygen in the heart of a white dwarf were not there when the star was born. They were made, slowly, in the star's own core, forged out of lighter elements across billions of years of patient burning. Every nucleus in that dense ember is a kind of memory, a record of the fusion that once lit the star. The helium pressed into carbon, the carbon touched into oxygen. The star spent its whole life making this ash, and now ash is all that remains, gathered close and held in the dark. There is a tenderness in that, if you let yourself feel it, the way a life leaves behind the quiet evidence of all it once did. And think of how many of these embers there are. The galaxy is old, and stars have been living and dying within it for a very long time, and so white dwarfs have been accumulating for ages, drifting among the living stars in uncountable numbers. They do not announce themselves. They are too faint, too small, but they are there, scattered through the dark, like the cooling coals of countless old fires, each one the quiet ending of a star that shone for ages. When you look up at the night and see only the bright, living stars, remember that between and around them drift these dim embers, far more numerous than they appear, a hidden population of the dead and resting, each one holding a sun's worth of crushed matter in the body of a world. So the ember has been set down, and we have walked all the way around it and seen where it came from and what it is made of and how many of its kind there are. Now at last it is time to go inside. Let us begin the slow descent down through the faint white glow, down through the still warm skin, down toward the place where the matter has been changed beyond recognition. Take a slow breath. There is no hurry. The ember has waited a long time, and it will wait for us a little longer still. Let us pause once more before we descend and consider the sheer ordinariness of the beginning, for it makes the ending all the stranger. The star we have followed was nothing special. It was a star much like billions of others, much like our own sun, a steady, quiet warmth that did the same gentle work for ages. There was no hint in all its long, shining life that it carried within it the seed of something so extreme. And yet, seed was always there, written into the simple fact that fuel runs out and gravity never rests. Every ordinary star carries the same quiet promise of this extraordinary ending, the same slow road from gathering cloud to swollen giant to fading ember. The white dwarf is not a rare accident. It is simply what happens in the end to the most common stars in the sky, given enough time. And time is the one thing the universe has in abundance. The road from a living star to a white dwarf is long beyond imagining, far longer than the whole history of life on Earth, far longer than the mountains and the oceans have held their shapes. A star spends billions of years in its steady shining, and only at the very end, in a span that is brief, only by comparison does it swell and shed its layers and settle into its ember form. We are seeing, when we look at a white dwarf, the patient work of an almost unthinkable stretch of time, gathered now into a single small dense thing that will itself endure for ages still to come. Think too of how quietly all of this happens. There is no audience for the death of most stars. They live and swell and fade in the silent dark, watched by no one, their planetary nebulae blooming and drifting apart with no eye to see the colors. The galaxy is full of these unwitnessed endings, these soft exhalations of light, these embers set gently down in the dark. And it strikes me as a tender thing that the universe should make such beauty and such strangeness with no need for it to be seen, simply as the natural consequence of a star running gently out of fuel. The white dwarf does not perform. It does not announce itself. It simply is what remains, glowing faintly, holding its impossible weight, waiting in the quiet. So let us go and visit one of these unwitnessed embers now, and be, for a little while, the eye that sees it. Let us descend slowly into the strangeness it holds, with all the patience the long road deserves. There is no hurry. The star took ages to become what it is, and it will hold its form for ages more, and we have only to follow it gently down, one quiet step at a time, into the place where the atoms come undone. Breathe in slowly, breathe out slower still, and let us begin to fall gently toward the ember. Let us talk about weight and about how heavy a small thing can be. Imagine you are holding an ordinary teaspoon. It rests easily in your fingers, light, enough that you barely notice it, the kind of small familiar object your hand knows, without looking. Now imagine filling that teaspoon, not with sugar, not with honey, but with a single scoop of the matter found inside a white dwarf. Just one level spoonful, no, more than you would stir into a cup of tea. That spoonful would weigh as much as an elephant. Sit with that for a moment, because it is the kind of fact that does not fit into the hand all at once. The spoon has not changed size. It is still small. It still looks like it could hold a sip of something sweet. But the matter inside it has been packed so tightly that those few grams of space now hold the weight of a large animal, several tons pressing down, far more than your arm could ever lift, far more than the table beneath it could bear. The spoon would tear straight through the table, through the floor, through anything we could build to catch it, drawn down by a weight that has no business living in something so small. This is the first strangeness of the white dwarf, and it is worth dwelling on slowly, because everything that follows grows out of it. The matter inside these dead stars is dense beyond anything in our ordinary world. Not a little denser, not twice as dense, or 10 times. Hundreds of thousands of times denser than anything you have ever held. Let us try the comparison another way, gently, with a different image. Think of a single matchbox, the little sliding kind that fits in a pocket. Empty it and fill it. Instead, with white dwarf matter packed in tight. That small box, light enough to flick across a table with one finger, would now weigh about as much as a few dozen cars, stacked together. You could not move it. You could not even nudge it. It would simply sit where it landed, sinking slowly into the ground, a tiny box too heavy for the earth to hold. Up. Or think of something even smaller, a single sugar cube, the kind that dissolves in a warm drink. A sugar cube of white dwarf material would weigh roughly as much as a truck. One small white cube, the weight of a vehicle you could not push. The mind keeps reaching for a way to make this ordinary, and it cannot, because there is nothing ordinary about it. This is matter that has been crushed into a state our world simply does not allow. And yet, here is the gentle wonder. This is not magic, and it is not violence. It is only crowding. The atoms are not heavier than the atoms in you. They are the same kinds of atoms, carbon and oxygen mostly, the very stuff of every living thing, the stuff of pencils and breath and the trees outside your window. There is nothing exotic about the ingredients. The only thing that has changed is how closely they are packed. Take ordinary matter, the most ordinary matter there is, and press it together until the empty room inside it is gone, and you arrive at this. Density is not a new substance. It is simply nearness taken to an extreme we never see. Now let us lift our eyes from the spoon and the matchbox and look at the whole object at once, because the scale of it is its own quiet astonishment. A white dwarf is about the size of the earth, not the size of a star, not the size of the sun, but the size of our own small planet, the one we stand on, the one that feels so vast when we try to travel across it. You could lay a white dwarf down beside the earth, and they would be near neighbors in size, two small worlds side by side, and into that small earth-sized ball is packed very nearly the entire mass of the Sunday. Hold those two facts together, side by side, and feel the strangeness open up between them. The sun is enormous. More than 1,000,000 Earths could fit inside it with room to spare. It is so large that its size is hard to even picture. A furnace so wide that light itself takes seconds to cross it. And all of that mass very nearly the whole of it, has been gathered up and pressed down into a sphere the size of the little world beneath your feet. It is as though someone took the entire contents of a great cathedral, every stone, every pillar, every soaring arch, and folded it all down into a single small room without losing a single stone. Nothing was thrown away. The weight is all still there. It has simply been brought close, impossibly close, until the cathedral fits inside the room. This is why the spoonful weighs as much as an elephant. It is the same fact seen from the other side. When you take the mass of a sun and fold it into the body of a planet, then every small piece of that body, every spoonful, every cube, every crumb must carry a share of that enormous weight. The density of the whole becomes the heaviness of each part. The two facts are one fact. Looked at from far away and from near, there is a gentle question that begins to stir here, and I want to let it surface slowly, the way a thought sometimes surfaces in the quiet just before sleep. How can matter do this? How can it be packed so tightly? What happened to all the room? Because ordinary matter, the matter we know, resists being squeezed. Press a stone and it pushes back. Squeeze water in a sealed container and it barely yields at all. The everyday world is firm. It holds its shape. It does not collapse into a fraction of its size simply because something leans on it. So how did the matter of a star allow itself to be folded down so far? The answer, which we will unfold slowly across the coming parts of our journey, is that ordinary matter is far emptier than it appears. The firmness we feel, the solidity of a table, the resistance of a stone, does not come from the matter being full. It comes from something else, something subtle, a kind of arrangement that can, under enough pressure, be undone. And when it is undone, when the emptiness inside matter is finally closed, you arrive at densities like these. The spoonful that weighs an elephant, the world that holds a sun. But we are not there yet. Tonight, in this part of the journey, it is enough simply to feel the weight. Let us not explain it away too quickly. Let us hold it first, turn it over, let it be, as strange as it truly is. So let us walk through the images one more time, slowly, the way you might walk through a quiet gallery, pausing at each one. Here is the teaspoon, holding the weight of an elephant in a scoop the size of a mouthful. Here is the matchbox, holding the weight of a row of cars in a box the size of your thumb. Here is the sugar cube, holding the weight of a truck in a cube that would dissolve in tea. Here is the whole white dwarf, a ball the size of the earth, holding the weight of the sun, glowing faintly in the dark. And here, perhaps, is the gentlest image of all. If you could somehow stand upon the surface of a white dwarf, which you could not, for its gravity would flatten you in an instant, but if you could, you would find that your own weight had become unthinkable. A person who weighs what you weigh on Earth would weigh, on the surface of a white dwarf, as much as a great mountain. The pull is hundreds of thousands of times stronger than the pull that holds you gently in your bed tonight. Every part of you would be drawn down with a force beyond anything a body could survive. I tell you this not to frighten, for there is nothing here to fear. The white dwarf is far away, drifting in the dark, harming no one. I tell you only so that you can feel from a safe distance. Just how deep this object's grip on itself must be. For if the surface pulls that hard, imagine the pull deeper down, near the center, where all the layers above press inward at once. Imagine the squeezing there. Imagine a force so patient and so relentless that it has folded a sun into a world and is still pressing, always pressing, never resting, never tiring. That squeezing is the second character in our story, the force that does the crushing, and we will follow it down into the dark soon enough. For now, let the density rest in your mind, like the small, heavy stone it truly is, a spoonful that weighs an elephant, a world that weighs a sun. Matter pressed so close that all the room has nearly vanished from it. It is one of the strangest facts in all the heavens, and it is true. Somewhere above you, beyond the ceiling and the roof and the thin blue skin of the sky, beyond the moon and the planets, out among the quiet stars, there are these small, dense embers, each one heavier than seems possible, each one a sun folded into a world, drifting in the dark and shining faintly and waiting. Let your breathing slow as we sit with this. There is no need to understand it all at once. The weight is allowed to be strange. The smallness is allowed to be astonishing. We have all the night ahead of us, and we will take the next step only when you are ready, down into the very structure of the atom, to find the empty room that all this weight has been pressing closed. Let us try one more way of feeling this density, because the mind needs many gentle attempts before such a thing begins to feel real. Imagine you could gather a single cubic centimeter of white dwarf matter, a little cube no larger than the tip of your finger, and set it upon an ordinary kitchen scale. The scale would read about a ton, the weight of a small car, balanced on a cube you could hide beneath your fingernail. The numbers refuse to settle into the ordinary. We say a ton, and the word is small and quick, but the thing it describes, a car's worth of weight in a fingertip of space, will not fit into the imagination no matter how patiently we turn it. And yet there is comfort in returning again and again to the simple reason behind it. Nothing exotic has happened. No strange new substance has been created. It is the same matter, the same carbon and oxygen that the dying star made in its core, the same kinds of nuclei that exist in the graphite of a pencil and the air you are breathing. Now, the only change is nearness. Take the ordinary and remove the room from inside. It and the ordinary becomes astonishing. Density, in the end, is one of the gentlest secrets in all of physics. It is not about adding, it is about closing the space. Consider how this density compares to the dense things we know on Earth. The densest ordinary substances we can hold, the heavy metals, gold and lead and the like, are dense because their atoms are heavy and packed reasonably close. A block of gold feels startling in the hand, far heavier than it looks, and yet white dwarf matter is not twice as dense as gold, or 10 times, or 100 times. It is tens of thousands of times denser and more. Set a block of gold beside a block of white dwarf matter of the same size, and the gold would feel like a feather, like nothing, like empty air. The whole range of heaviness we know on Earth, from the lightest gas to the densest metal, is crowded together at the very gentle end of a scale. that the white dwarf has climbed far, far beyond, there is a quiet question that sometimes arises here, and it is worth answering softly. If the matter is so dense, why does the white dwarf not simply collapse further? Why does it stop at the size of a world rather than continuing to shrink? The answer is the deep heart of our whole journey, and we will arrive at it in its own time. For now, it is enough to know that something inside this crushed matter pushes back, something that grows stronger the more the matter is squeezed, a quiet stubbornness woven into the smallest pieces of nature. Without it, the densities we are marveling at could never hold. They would be only a moment in a longer fall. But the stubbornness is real, and so the density is stable, frozen at this astonishing value, held there for ages. Let us also feel the strangeness of the surface, the outer skin of this small, heavy world. Because the gravity at the surface is so immense, anything that fell toward a white dwarf would be drawn down with terrible swiftness, and anything resting upon it would be flattened beyond recognition. A mountain on a white dwarf could be no taller than a pebble, for the crushing gravity would not allow any height to stand. The surface is smoother than anything we know, smoother than glass, smoother than still water, a near perfect sphere with no room for hills or valleys, every irregularity pressed flat by the same gravity that folded the sun into a world. Picture that surface in your mind, a vast, smooth, dimly glowing skin, curving away in every direction, perfectly even, perfectly quiet, holding within it the strangest matter in all the heavens. And feel, one more time, the ratio at the center of it all, for it is the thing most worth, carrying with you a body the size of the earth, the weight of the Sunday. These two facts, held side by side, are the whole astonishment in a single image. Everything else, the spoonful and the matchbox and the sugar cube, is only this same truth broken into pieces small enough to hold. The sun folded into the earth, the cathedral folded into the room, the weight of a star gathered into the body of a world, drifting quiet and smooth and impossibly heavy in the dark. Rest with that a while. There is no need to resolve the strangeness or to make it ordinary. Some facts are meant to stay astonishing. Let this one be. Let it sit in your mind like the small, heavy stone it is, cool and smooth and far heavier than it looks, while your breathing slows and your thoughts grow soft, and we prepare to go down inside the matter itself, to find the empty room that all this weight has been quietly pressing closed. There is a further wonder hidden in this density, one that rewards a little quiet attention. Because the matter is packed so tightly, light itself behaves strangely as it climbs away from the surface of a white dwarf. The immense gravity drags on the light, tiring it ever so slightly as it leaves, stretching it toward the redder end of its color. Astronomers can measure this gentle reddening, and from it they can weigh the star, reading its hidden mass in the faint, tired glow of its escaping light. So the density does not only crush, it leaves a fingerprint upon every ray that departs, a soft signature written into the color of the light, by which we can know the weight of a thing we will never touch. And think too of how the density changes as we move inward through the star. The outer skin, thin and comparatively light, is not so very far from ordinary matter, but as We descend, layer upon layer, pressing down from above. The matter grows denser and denser, crushed harder by the weight of everything stacked over it, until at the very center, the density reaches its greatest extreme, far beyond even the astonishing average we have been describing. The heart of a white dwarf is the densest ordinary matter in the calm universe, surpassed only by the still stranger hearts of the neutron, stars, which are a tale for another night. Picture that gradient, that slow deepening of weight as we sink toward the center, each layer heavier than the last, the matter growing more crushed and more strange with every step down. Hold all of this gently together now, the tired reddened light climbing away, the perfectly smooth flattened surface, the deepening density toward the core, the block of gold that would feel like a feather beside it, the spoonful, the matchbox, the sugar cube, the world that weighs a sun. Each image a different doorway into the same single astonishment, the astonishment of matter pressed closer than our world allows. We will pass through one more doorway in the next part of our journey, the strangest and most revealing of them all, when we go inside a single atom and find the empty room that all this weight has been folding closed. For now, let the weight rest in your mind, heavy and smooth and quiet, while your own body grows a little heavier against the bed, and your breathing slows, and the strange dense ember turns gently in the dark. To understand how a star can be folded so small, we have to go smaller still into a single atom. And there we find one of the most beautiful and least believed facts in all of nature. The atom is almost entirely empty. Let us approach this gently, because it overturns something the body feels certain of. Your hand feels solid, the table feels solid, the floor holds you, the wall stops you, the cup keeps its shape in your grip. Everything in the everyday world announces itself as full, as substantial, as packed tightly together, and yet the truth, when we look closely enough, is the opposite. The fullness is an illusion. What feels solid is mostly room. Imagine a single atom. At its center sits the nucleus, the dense little knot where nearly all the atom's weight is gathered. Around it, far away, drift the electrons, the faint and restless outer presence of the atom. And between the nucleus and the electrons there is nothing at all, empty space, a great vacant distance with no stuff in it whatsoever. Let us blow the atom up, gently, in our minds, until it is large enough to walk through. Picture the nucleus at the center as a single small marble set down in the middle of a vast empty cathedral, the kind of hall where your footsteps echo and the ceiling is lost in shadow far above. That marble is the nucleus, where almost all the weight lives, and the electrons. Where are they? They are not nearby. They are out at the very walls of the cathedral, drifting near the distant windows, a whole hall away from the little marble at the center. Between the marble and the walls there is only emptiness, vast and quiet, filling nearly the entire atom. This is genuinely true to the proportions. If the nucleus were the size of a marble, the atom around it would be the size of a cathedral or a stadium or a small mountain, almost all of what we call an atom is empty room. The solid part, the part with the weight in it, is a tiny speck lost in a great hall of nothing. And here is the gentle astonishment. You are made of these atoms, every one of them, in your hand, in your heart, in the bone and blood and breath of you, is a tiny dense speck adrift in an enormous emptiness. Stack these mostly empty cathedrals together by the countless billions, and you get a hand, a table, a stone, a world. The solidity you feel is not the fullness of matter. It is the way the distant electrons push back against each other when two objects meet. When your hand rests on the table, the atoms of your hand never truly touch the atoms of the table. They cannot. The outer electrons of one come near the outer electrons of the other, and they push apart, like the same poles of two magnets refusing to meet. What you feel as touch, as the firm, cool surface of the table, is really that gentle electric refusal. The electrons of two great emptinesses declining to overlap. You have never truly touched anything in your life. You have only felt the pushing of the emptiness, held a hair's breadth apart. This is not a sad thought, it is a wondrous one. The firm and reliable world of surfaces and shapes is built almost entirely out of room, held in place by the lightest and most delicate of forces. The chair holds you up by the faintest of arrangements. The ground beneath your feet is a vast lattice of empty cathedrals, each a marble lost in a hall, all of them leaning gently against one another through the pushing of their distant electrons. When you lie down tonight, the bed that holds you is mostly empty space, and so are you. And the holding itself is only the faintest electric refusal of one emptiness to overlap another, and yet it holds. It has always held. The most delicate arrangement in all of physics has carried your whole weight faithfully every moment of your life, without once failing. Now hold that picture of the cathedral in your mind, the marble at the center, the electrons at the far walls, the great empty hall between, and ask the quiet question this whole journey has been circling toward. What would happen if you could close that hall? What if something pressed on the cathedral from every side at once, so hard, so relentlessly, that the walls began to move inward? The electrons would be driven in from their distant rooms, closer and closer to the marble at the center. The vast empty space would shrink, and if the pressing continued, the cathedral might collapse down toward the size of the marble itself, all that emptiness squeezed out. Now imagine doing that, not to one cathedral, but to every atom in an entire star, all at once, all of them giving up their empty halls. That is the white dwarf. The matter inside it has had its emptiness closed, but what could press so hard? What force could overrule the electric refusal that holds the cathedrals open, the refusal that easily bears the weight of mountains? To find it, let us follow the one force patient enough and relentless enough to do it. Let us follow gravity. Gravity is the gentlest force in the universe, and also the most relentless. It is gentle because it is weak. Between two small things, two pebbles, two people, the pull of gravity is so faint we never notice it at all. A small magnet can lift a paperclip against the gravity of the entire Earth, the whole weight of the planet pulling down, overcome by a force you can hold in your palm. By every ordinary measure, gravity is almost nothing. And yet gravity rules the cosmos, and its secret is patience and addition. Every scrap of matter pulls on every other scrap, always, everywhere, never resting. The stronger forces tend to cancel out over large distances. Attraction matched by repulsion until almost nothing remains. But gravity never cancels. It only ever pulls, never pushes. And so every scrap of matter adds its small pull to every other, and nothing ever subtracts. Across a whole star, those countless tiny pulls accumulate without any opposing pull to undo them, until the feeble force becomes a giant. Gravity wins not by being strong, but by being relentless, by never resting, by adding forever and never taking away. In a living star, gravity is held at bay. While the fire burns in the core, the star is a place of perfect balance. Gravity pulls every scrap of the star inward. The fire pushes back, flooding outward with heat and pressure, holding the inward pull exactly in check. The star is a great quiet argument between two enormous forces, and for billions of years, neither one wins. It holds its size, it shines, it rests in its own balance, like a held breath. But we have followed this star to the end of its life. The fire has gone out. The fuel is spent. And in that moment, the argument ends, because one side has simply stopped speaking. Gravity does not stop. Gravity never stops. It was pulling all along every moment of those billions of years, and it is pulling still, exactly as hard as before. What has changed is that nothing is pushing back. And so, for the first time in the star's long life, gravity is free to do what it has always wanted to do. It begins to squeeze. Picture it gently. The core of the dead star, still warm, still glowing, begins to settle inward. There is no explosion, no drama. It is a slow sinking, a great soft collapse as every layer presses down upon the layers below, all the way to the center, where the weight of everything above gathers into a single crushing inward pull. The star begins to shrink, and as it shrinks, gravity grows stronger, for the closer matter is gathered, the harder gravity pulls it together, and the harder it pulls, the closer it gathers. So the collapse feeds itself, growing more relentless as it goes. Now remember the cathedrals. As gravity presses the star inward, it is pressing on those empty halls. It leans on them from every side at once, the whole weight of the dying star bearing down, and the halls begin to give way. The electrons, out near the windows, are pushed inward from their distant rooms. The vacant space begins to close. In the everyday world, this could never happen, for the electric refusal far outmatches any ordinary weight. Lean on a stone and the cathedrals hold easily. Stack a mountain and still they hold. But the gravity of a collapsing star is not an ordinary weight. It is the gathered pull of an entire sun, focused inward, growing as it goes. And against that, the gentle refusal is not enough. The halls fold shut. Feel what is happening, for it is the very crushing the title speaks of. In ordinary matter, each electron keeps to its own atom, circling its own marble, belonging to its own tidy household. But as gravity squeezes the star, the households are pushed together until their walls overlap, until one atom's empty hall presses into the next, and the electrons can no longer tell which marble is their own. The households break apart. The electrons are squeezed out of their separate rooms and pressed into one great shared crowd, no longer belonging to any single atom, but flowing freely among all of them. The nuclei, the dense little marbles, remain, for they are far heavier and smaller and harder to merge, but they too are driven close together, packed into the shrinking space, while around them the electrons swarm in a single dense sea, and still the collapse continues. Still gravity presses inward, never resting, gathering strength as the star grows smaller. The electrons are forced closer and closer together, crowded beyond anything that happens in ordinary matter, beyond anything that happens on Earth. Here we arrive at the edge of the deepest mystery in our story. By every rule of the gentle everyday world, the collapse should not stop. Gravity is relentless. It never tires. It only grows stronger as the star shrinks. The fire is gone. The electric refusal has been overrun. The cathedrals have folded shut. What, then, could possibly stand against a force that has already folded a sun toward the size of a world and is pressing still? And yet something does. The collapse does not run away to nothing. The white dwarf is the proof, sitting stable and patient at the size of a world, neither growing nor shrinking, held at exactly the size where the falling stopped. Something caught it. Something rose up out of the crushed crowd of electrons and pushed back against the weight of a sun and said, with a strength that comes from nowhere we would expect, here and no further. We stand now at that threshold, in the dark near the center, where the electrons are, crushed beyond all ordinary closeness, and the pressing of gravity meets. For the first time, something it cannot overcome. Breathe slowly and feel the two great forces poised against each other. Gravity, pressing inward, gathered from a whole sun, and just beginning to rise against it. The crushed together electrons, stirring with a strange new resistance we have not yet named. In the next part of our journey, we will learn at last what holds the falling star, the gentle, stubborn rule woven into the smallest pieces of matter, the rule that lets a dead sun rest in the dark instead of vanishing into a point. Before we cross that threshold, let us dwell a little longer in the two ideas we have just met, the emptiness and the pressing, for they are the whole foundation of what comes next, and they are restful things to hold. Consider once more how strange it is that the emptiness inside an atom has a shape. The electrons do not drift just anywhere in the great hall. They keep to certain regions, certain distances from the central marble, arranged in shells and layers like the soft rings of an onion drawn in light. Each shell is a kind of floor in the cathedral, a level at which the electrons are allowed to rest. And between the floors there are spaces where no electron ever lingers. This orderly filling of floors, shell upon shell, is what gives each kind of atom its character, and it will matter greatly in the next part of our story, for it is the very rule that will catch the falling star. For now, simply feel the architecture of the emptiness, a marble at the center, floor upon floor of permitted space, and the vast, quiet vacancy filling all of it. Let us make the emptiness even more vivid. for the proportions are almost beyond belief, and yet they are true. If you grew a single atom until its nucleus were the size of a small fruit set in the middle of a great field, then the nearest electrons would be drifting somewhere near the distant edge of that field, hundreds of paces away, and everything in between. The whole vast field would be empty, not thin, not nearly empty, empty, an entire field of nothing wrapped around a single piece of fruit. And you are built of these fields, countless billions upon billions of them, woven together. If you could squeeze out all the vacant fields and gather only the dense central specks of your whole body, you would shrink to something far smaller than a grain of dust, while keeping every bit of your weight. This is not idle imagining. It is, in a quiet way, exactly what gravity does inside a dead star. It closes the fields, it folds the cathedrals, it drives the distant electrons inward and squeezes the vacant space out until the dense specks are packed close together and the matter shrinks toward the size of its own substance while keeping all of its enormous weight. The white dwarf is what you get when the emptiness of ordinary matter is taken away. It is the field with the grass mown down to nothing, only the central fruit remaining, packed close with all its kind. Now feel the pressing from another angle by standing, in imagination, upon the surface of the dead star. You could not truly stand there, for its gravity would flatten you in an instant. But imagine it from a safe distance. A person who weighs what you weigh on Earth would weigh on the surface of a white dwarf as much as a great mountain. The pull is hundreds of thousands of times stronger than the gentle pull that holds you in your bed tonight. And if the surface pulls that hard, imagine the pressing deeper down where all the layers above bear inward at once. As we sink toward the center, the matter grows denser, crushed harder by the weight of everything stacked over it, until at the very heart, the squeezing reaches its greatest extreme, far beyond anything our world allows. Picture that slow deepening of weight as we descend, each layer heavier than the last, the cathedrals folding more completely with every step down. There is a tender thought hidden in all of this, and I will offer it softly. The solidity of the world is among the gentlest illusions in all of nature, and so is your own. You are mostly empty space, vast halls of quiet vacancy held together by the faintest electric refusal, and that refusal has carried you faithfully your whole life long. The same is true of the bed beneath you, the floor, the walls, the whole patient room. It is all mostly nothing, and the nothing has held you, and it holds you still. And out among the stars in the still, warm hearts of the embers, that same nothing has been folded shut, the halls pressed, flat, the fields mown down by the patient, relentless pull of gravity that never cancels and never rests. So let the room around you grow soft and open. Let your breathing widen into the quiet. You are mostly space, and the space has always held you, and it holds you now as we turn together toward the gentle, stubborn rule that will catch the falling star and hold the ember open in the dark. Carry the two pictures with you across the threshold. The empty cathedral, the marble, lost in its vast hall. The same emptiness that fills your hand and your heart and the bed beneath you. and the patient pull gathered from a whole sun leaning on those halls, from every side, folding them shut. When the one meets the other, when relentless, gravity presses on the empty cathedrals with nothing to stop it, the halls collapse and the star folds down toward the impossible density we have marveled at. But the halls do not collapse forever. Something halts them gently and completely, just as the walls are closing in. And that something is where we go next, into the quiet rule that braces the folded cathedrals open and lets the ember rest at last in the dark. Now we meet the quiet hero of the whole story. It does not have a dramatic name. It is called the Pauli exclusion principle, and from it comes a strange pressure called electron degeneracy pressure. Let us take those words apart slowly and gently until they feel less like jargon and more like the simple, wondrous truth they describe. Begin with the electrons, the small, restless presences that drift in the halls of every atom. Electrons follow rules unlike anything in the world we can see. They are not tiny balls, though we often picture them that way. They are something subtler, governed by the deep laws of the very small, the laws we call quantum. And one of those laws is a rule about sharing. The rule is this: no two electrons are allowed to be in exactly the same state at the plus same time in the same place. Each electron must have its own state, its own particular arrangement of motion and position and spin, its own seat, if you like, in the great hall of possibilities. Two electrons cannot sit in the same seat. They simply cannot. It is not that they choose not to, or that they push each other away by some force. It is deeper than that. The laws of nature forbid it outright. Each electron must have a seat of its own. This is the Pauli exclusion principle, and it sounds like a small and technical thing, but hold on to it, because it turns out to be one of the great pillars holding up the world. It is the reason atoms have structure at all, the reason electrons arrange themselves in shells and layers, rather than all collapsing into the lowest possible state. Each electron must take its own seat, and so they stack up, filling seat after seat, level after level, building the orderly structure that gives every element its character. Without this rule, all the electrons in every atom would crowd into the same lowest state, and chemistry would not exist, and neither would you. The exclusion principle, this quiet refusal to share a seat, is woven into the foundation of all ordinary matter. Now let us bring this rule into the heart of the collapsing star and watch what it does. Remember where we left the electrons. Gravity had crushed them together, squeezing them out of their separate atoms, pressing them into a single dense crowd. Closer and closer they were driven, packed into less and less room. And here is where the exclusion principle awakens. For as the electrons are pressed together, they begin to run out of seats. Picture a great hall filling with people. When the hall is nearly empty, everyone can sit wherever they like, in the most comfortable seats, near the floor, at rest. But as more and more people are forced in, the comfortable seats fill up, the low seats are taken, and by the rule that no two may share a seat, the newcomers have no choice but to climb to higher seats, and then higher still, filling the hall upward, level by level, whether they wish to or not. There is simply nowhere else for them to go. For electrons, the seats are states of motion. The low seats are slow, gentle motion. The high seats are fast, furious motion. And so, as gravity crushes the electrons together and the low, slow seats fill up, the electrons are forced into higher and higher seats, which means faster and faster motion, not because they are heated, not because anything is pushing them, but simply because there is nowhere else for them to be. The rule forbids them from settling into the seats already taken. So they must move fast, faster and faster, the more they are crushed. And here, at last, is the source of the pressure that holds the star open. All those electrons forced into furious motion by the exclusion principle, refusing to share their seats, hurtling about because they have no slower seats left to occupy, push outward against the squeezing of gravity. They resist being crowded any closer, because to crowd them closer would mean forcing them into even higher seats, even faster motion, and that resistance, that refusal to be packed any tighter, becomes a pressure. We call it electron degeneracy pressure, and it is the force that catches the falling star. Let us sit with how strange this pressure is, because it is unlike any pressure in the everyday world. The pressure in ordinary things comes from heat. Warm a gas and its particles fly about, faster, pushing harder on the walls of their container. Cool it down and the pushing fades. This is the pressure we know, the pressure of warmth, and it always softens as things grow cold. The fire in a living star pushes outward this way with the pressure of heat, and when the fire dies, that pressure dies with it. This is why the dead star began to collapse in the first place. But degeneracy pressure is different. It does not come from heat at all. It comes from the crowding itself, from the exclusion principle forcing electrons into fast motion simply because they have run out of slow seats. This means it does not fade as the star cools. You could chill the white dwarf to the very edge of absolute cold, draw out every last whisper of its warmth, and the degeneracy pressure would not weaken in the slightest. The electrons would still be crushed together. The seats would still be full. They would still be forced into furious motion by the rule that forbids sharing. And so they would still push outward just as hard, holding the star open with a strength that owes nothing to temperature. This is the deep beauty of it. The white dwarf is held up not by fire, not by heat, not by anything that can burn out or fade away, but by a rule, by the simple refusal of electrons to share a seat. The star will cool across the ages, dimming from white to red to the band, faintest ember, losing all its warmth to the dark. And through all of that, the degeneracy pressure will hold steady, bracing the folded cathedrals open, keeping the star at the size of a world forever, long after the last of its heat has drained away into the night. There is something almost tender in this, if you let yourself feel it, a force woven into the foundations of matter, quiet and unfailing, that asks for no fuel and gives off no light, that simply holds and holds and holds. Gravity presses inward with the gathered weight of a sun, and this gentle, stubborn rule pushes back with exactly enough strength to say, here and no further. And the two settle into a balance so perfect and so patient that the star can rest in it for longer than the present age of the universe, neither growing nor shrinking, an ember held open by nothing more than the way the smallest things in nature refuse to be the same. Let us name what this means for the matter inside the star, because it is part of the wonder. When matter is held up this way, by the crowding of its electrons rather than by heat, we say it has become degenerate. It is a strange word, but it carries no insult. Here, it means only that the electrons have filled their seats from the bottom up, packed as tightly as the rule allows, every low seat taken, the whole crowd forced into the orderly stacked motion that the exclusion principle demands. Degenerate matter is matter that has surrendered its ordinary structure and reorganized itself around this single deep rule. It behaves unlike anything we know. It conducts heat with astonishing ease, flowing warmth through itself, almost the way a metal does, but far more so. It resists compression not gently but fiercely, growing harder to squeeze the more you press, like a substance that pushes back with all the stubbornness of a law of nature, because that is exactly what it is. And so the falling star is caught. The collapse that seemed unstoppable, the relentless folding of gravity that overran the fire and crushed the cathedrals and pressed the electrons into a single dense crowd, finally meets something it cannot overcome. Not a wall, not a force we could build or touch, only a rule, only the quiet refusal of electrons to share a seat, rising up out of the crushed together crowd to push back against the weight of a sun. And it is enough. It is exactly enough. The star stops falling. It settles. It rests at the size of a world, held open by the deepest stubbornness in nature. And it begins its long, quiet life as an ember in the dark. Breathe slowly and feel the steadiness of this balance, the way you might feel the steadiness of your own held weight upon the bed, supported without effort, going nowhere, simply resting. The star is resting too, caught between two great forces in perfect silent agreement. Gravity says inward, the rule says here, and no further. And in the space between them, held open by a law older than the star itself, the ember glows on, while inside it the matter has become something we are only now ready to truly see, something where the atoms themselves have lost their names. That is where we go next, into the heart of the degenerate sea, to look upon matter that has been crushed beyond all recognition. Let us sit a while longer with this rule, the refusal of electrons to share a seat, because it is so strange and so quiet and so central to everything that holds the world together, and it deserves to be turned over slowly in the pie. Dark. It helps to feel how unlike anything in ordinary life this rule truly is. In the world we know, things can share. Many people can stand in the same field. Many drops of water can gather in the same pool. There is no law that forbids two ordinary things from being in the same kind of place, doing the same kind of thing. Crowding is uncomfortable, perhaps, but never forbidden. And so we have no everyday picture for a rule that says, absolutely and without exception, that two of these tiny things may never occupy the same state at once. It is a rule with no echo in the world our hands can touch. It belongs entirely to the realm of the very small, the quantum realm, where the deepest laws of nature behave in ways that our ordinary intuition was never built to hold. And yet this strange rule, so foreign to everyday life, is the reason everyday life exists at all. Think again of the atom, the marble at the center, the floors of permitted space around it. The electrons fill those floors from the bottom up, one to each available seat, because no two may share. This is why atoms have their layered structure, their shells filling in order, their outermost electrons left exposed to join with other atoms. All of chemistry, all the joining and bonding that builds water and air and stone and living tissue, depends on this orderly filling. If electrons were allowed to share seats freely, they would all collapse into the single lowest state of every atom. The shells would vanish, the structure would disappear, and there would be no chemistry, no variety of elements, no molecules, no life. The whole rich world is built upon this one quiet refusal. The same rule that holds the dead star open is the rule that lets you exist to wonder about it. Now let us return to the crushed crowd of electrons in the heart of the collapsing star and watch the rule do its great work. More slowly this time, gravity has driven the electrons together out of their separate atoms into a single dense crowd. And as the crowd grows denser, the electrons begin to run out of the slow, gentle seats, the low states of lazy motion. By the rule, no two may share a seat. So as the low seats fill, each new crowding forces electrons up into higher seats, faster motion, whether they wish it or not. The denser the crowd, the higher the seats that must be filled, and the faster the electrons at the top of the crowd are forced to move. This forced motion is not warmth. It would be there even at the very edge of absolute cold. It is the pure consequence of crowding under the rule, the electrons hurtling about, not because they are hot, but because there is simply nowhere slower left for them to be, and all that forced motion presses outward. The electrons resist being crowded any closer, because to crowd them closer would force them into even higher and faster seats. And that resistance becomes a pressure, the degeneracy pressure, pushing back against the squeezing of gravity. Here is the quiet beauty of it. The more gravity crushes the electrons, the higher the seats they are forced into, and the harder they push back. The pressure grows as the crowding grows, and so, at last, there comes a density at which the outward push of the crowded electrons exactly matches the inward pull of gravity, and the collapse comes to rest. The star stops falling, it settles into balance, held open by nothing more than the refusal of its electrons to share a seat. Feel how different this is from the pressure of fire. The fire that held the living star open was the pressure of heat, and heat fades. Cool the fire and the pressure dies. This is why the dead star collapsed in the first place, because the heat that held it open had drained away. But degeneracy pressure does not come from heat. It comes from the crowding and the rule, and neither of those fades with cooling. You could draw every last whisper of warmth out of the white dwarf, chill it toward the absolute cold, and the electrons would still be crowded, the low seats would still be full, the rule would still forbid sharing, and the outward push would not weaken at all. This is why the white dwarf can cool forever and never collapse. The thing that holds it open owes nothing to its warmth. It is held not by fire, but by law, and the law does not grow cold. There is something deeply moving in this, if you let the feeling come. The living star held itself open through constant effort, burning its fuel, fighting gravity with the outward flood of its fire, a great straining argument that could only last as long as the fuel lasted. But the dead star holds itself open effortlessly, without burning anything, without spending anything, simply by being what it is, simply by the refusal of its electrons to share a seat. The struggle is over. The fire is no longer needed. The star has found a way to rest against its own gravity without effort, held open by a quiet rule that asks for nothing and never tires. It is a kind of peace, this degeneracy, a final settling into a balance that needs no fuel and no fighting, only the deep stubbornness woven into the smallest pieces of itself. Let us name gently what this means for the matter of the star. We say that such matter has become degenerate, and the word carries no insult here, only a description. It means the electrons have filled their seats from the bottom up, packed as tightly as the rule allows, the whole crowd forced into the orderly stacked motion that the rule demands. Degenerate matter behaves unlike anything we know. It conducts heat through itself with extraordinary ease, almost instantly, so that the whole deep interior, the star stays nearly the same warmth throughout. It resists being squeezed not gently, but fiercely, growing harder to compress the more it is pressed, pushing back with all the authority of a law of nature, because that is precisely what it is. It is matter that has reorganized itself entirely around this single deep rule, set down its ordinary structure, and become a new kind of substance, governed not by the gentle forces of chemistry, but by the quiet iron refusal of the exclusion principle. And so the falling star is caught. The collapse that seemed unstoppable, the relentless folding of gravity that overran the fire and crushed the cathedrals and pressed the electrons into a single dense crowd, finally meets something it cannot overcome. Not a wall, not a force we could build or touch, only a rule, only the refusal of electrons to share a seat, rising up out of the crushed crowd to push back against the weight of a sun. And it is enough. It is exactly enough. The star stops falling. It settles. It rests at the size of a world, held open by the deepest stubbornness in nature. And it begins its long, quiet life as an ember in the dark. Breathe slowly and feel the steadiness of that balance, the way you might feel the steadiness of your own held weight upon the bed, supported without effort, going nowhere, simply resting. The star is resting too, caught between two great forces in perfect, silent agreement. Gravity says inward, the rule says here, and no further. And in the space between them, held open by a law older than the star itself, the ember glows on, while inside it, the matter has become something we are only now ready to truly see, something where the atoms themselves have lost their names. That is where we go next, into the heart of the degenerate sea, to look upon matter that has been crushed beyond all recognition. Now we have arrived. We stand, in our imaginations, deep inside the white dwarf, in the crushed heart of the ember, and we are ready to look directly at what the matter here has become. This is the heart of our story, the place the title points toward. Inside a white dwarf, the atoms are crushed beyond recognition. Let us see, slowly and gently, exactly what that means. Up in the gentle world, an atom is a tidy thing, a nucleus at the center, the dense little marble. Around it, in their distant halls, the electrons, each belonging to this atom and no other, each circling its own home, arranged in orderly shells. The atom keeps its boundaries. It knows where it ends and where the next atom begins. And because each kind of atom has its own particular arrangement of electrons, each kind behaves in its own particular way. Carbon behaves as carbon. Oxygen behaves as oxygen. The electrons in their shells are what give each element its character, its way of joining with others, its color, its chemistry, its identity. Now look at what has happened here, in the crushed heart of the star. The boundaries are gone. The tidy households have been broken open. Gravity pressed the atoms so close together that their distant electron halls overlapped and merged, and the electrons were squeezed out of their separate homes into a single shared crowd. There is no longer any way to say which electron belongs to which nucleus. They do not belong to anyone. They flow freely through the whole crushed mass, a single vast ocean of electrons, filling every space, drifting among all the nuclei at once. And the nuclei, the dense little marbles, they remain, for they are far heavier and far smaller and harder to merge. But they no longer sit at the center of their own private halls. They are bare now, stripped of the electron shells that once surrounded them, drifting like scattered stones in the great electron sea. They are packed close together, far closer than atoms ever sit in ordinary matter, crowded into the small space. The collapse has left them, but they are naked. They have lost their clothing of electrons. They are no longer atoms. They are only nuclei, bare and stripped, adrift in an ocean that belongs to no one. This is the strange new substance at the heart of the white dwarf. Not a gas of atoms, not a solid of atoms, not atoms at all, in any way you would recognize. It is a sea of free electrons, crushed together and forced into furious motion by the rule we met. And within that sea, scattered like grains, the bare nuclei of what were once carbon and oxygen, stripped of their shells, drifting and jostling in the dense electron tide. Let us feel what has been lost, because the losing is part of the wonder. Chemistry is gone. In the gentle world, atoms join with one another, share their outer electrons, build molecules, build water and air and stone, and the living tissue of every breathing thing. All of that depends on the electron shells, on each atom keeping its own electrons in their own arrangement, ready to bond and join and combine. But here the shells are gone. The electrons belong to no atom. There is nothing to bond, nothing to join, no molecules, no chemistry, none of the rich combining that builds the world we. No, the matter of the star has fallen beneath chemistry into a state simpler and stranger, where the only thing that matters is the crowding of the electrons and the bracing pressure it provides. Identity is gone. In the gentle world, carbon is carbon and oxygen is oxygen. each behaving in its own way because of its own electron arrangement. But here, with the electrons stripped away and pulled into a common sea, the difference between carbon and oxygen has almost dissolved. What remains are bare nuclei of slightly different weights, drifting in the same shared ocean, no longer behaving as the proud, distinct elements they once were. The matter has forgotten, in a sense, what it used to be. It has set down the names carbon and oxygen and become simply degenerate matter, a single quantum substance, behaving as one connected body rather than as a collection of separate atoms, each insisting on itself. And here is the poetic reframe, the thing worth carrying with you into sleep. The matter inside a white dwarf is no longer made of atoms in any way we would recognize. It is made of something more unified, more woven together, a single vast sea of electrons, threaded through with bare drifting nuclei, the whole of it behaving as one body, governed by one deep rule. The individuality of the atoms, the very idea of separate building blocks, each keeping to itself, has dissolved into a kind of unity, where once there were countless tiny separate households, each a marble in its own private hall. There is now a single shared ocean, vast and crowded and humming with forced motion, in which the old boundaries have melted away. There is something to sit with there in the quiet. The matter of the star has given up its separateness. The walls between the atoms have come down. What was many has become, in a strange and literal way, more like one. The electrons no longer say, "This is mine and that is yours." They flow together, shared among all, a single connected presence filling the whole crushed heart of the ember. Let us also feel what has been gained, because it is not only loss. This new substance has properties that ordinary matter can only dream of. Because the electrons flow so freely, the degenerate matter conducts heat through itself with extraordinary ease, far better than any metal, so that warmth spreads through the whole interior of the star almost instantly, keeping the deep inside nearly the same temperature throughout. A vast, even warmth held in a single connected body. And because the pressure holding the star open comes from the crowding rather than from heat, the matter is astonishingly stable. It does not need to burn. It does not need to be fed. It simply holds, braced by the rule, indifferent to the slow draining away of its warmth, and the matter resists being squeezed with a fierce, strange stubbornness. Press on, ordinary matter, and it yields a little and then pushes back gently. But press on, degenerate matter, and it pushes back harder and harder, growing stiffer the more you crowd it. Because every increase in crowding forces the electrons into even higher, faster seats, and they resist that with all the authority of a law of nature. It is matter that has become, in a sense, almost incompressible, a substance so braced by the exclusion principle that it can hold the weight of a sun without yielding, the same substance that lets the spoonful weigh as much as an elephant and the world hold the mass of a star. So when we say the atoms inside a white dwarf are crushed beyond recognition, we mean it in the fullest and most literal way. We do not mean only that they are squeezed tightly. We mean that the very thing that makes an atom, the private hall, the bound electrons, the boundary between one and the next, the element's own identity, all of it has been undone. The atom, that ancient idea of the smallest separate piece of ordinary matter, has been pressed out of existence in here, replaced by something with no name in everyday speech, a degenerate sea of electrons and bare nuclei behaving as a single quantum whole. This is matter as it exists nowhere on Earth. We can study it, we can understand it through the deep rules of physics. We can even, in the faintest and most fleeting way, glimpse hints of such states in our laboratories. But we cannot hold it. We cannot make it stay. It can only exist where gravity grows strong enough to fold the cathedrals shut and crowd the electrons into their forced and furious sea. And that means it can only exist in the still hearts of the dead stars, out in the dark, far from any hand. And so, when you imagine a white dwarf now, do not imagine a small ball of ordinary stuff. Imagine instead this strange unified substance, this ocean of shared electrons, threaded with naked nuclei, this single connected quantum body where the atoms have set down their separateness and their names. Imagine matter that has forgotten how to be many and learn it under the pressing of gravity how to be one. It glows faintly in the dark, this strange sea, warm and even throughout, braced open by a quiet rule, holding the weight of a sun in the body of a world, while the old familiar atoms it was, born from rest, crushed beyond recognition in its depths. Breathe slowly and let that image settle over you like a soft, heavy blanket. The sea of electrons, humming with forced, gentle motion. The bare nuclei drifting like scattered stones. The boundaries dissolved, the separateness given up, the whole crushed heart of the ember resting as a single, quiet, connected thing. There is something restful in it, this dissolving of boundaries, this becoming one. The matter is not struggling, it has found its balance. It has set down its old shape and settled into a new one, and it holds there, peaceful and unburning, in the dark for a very long time. Let us stay here a while, in the crushed heart of the ember, and look more slowly at this strange, unified substance, for it is the very thing the title promises, and it rewards a long, gentle gaze. Think first of how much has been undone. In the gentle world above, the word atom names the smallest piece of a thing that still behaves as that thing. A single atom of gold is still gold. A single atom of oxygen still longs to join with others in the way oxygen does. The atom is the smallest unit of identity, the smallest scrap that still remembers what it is. And here, in the heart of the white dwarf, that smallest unit of identity has been broken. The electrons that carried the identity, that gave each element its way of being, have been stripped away and poured into a common sea. What remains is no longer gold or oxygen or carbon in the way we mean those words. The matter has fallen beneath the level of identity into a state more basic and more unified, where the question of what element is this has almost lost its meaning. It is worth pausing on that gently, because it is a profound thing. We tend to think of the elements as fixed and eternal, as the true names of matter, the unchangeable alphabet, from which everything is spelled, and in the gentle world they nearly are. But here we learn that even the elements are, in a sense, a feature of low pressure, a luxury of calm and spacious world. Crush matter hard enough, and the elements blur together, their distinguishing electrons merging into one shared ocean, their proud identities, dissolving into a common degenerate substance. The alphabet of matter is not quite as eternal as it seems. Press hard enough and the letters run together into a single flowing ink. Now feel the unity of what remains, for it is the deep poetic heart of this part. Up in the gentle world, matter is a crowd of separate individuals, each atom a tiny private household, each keeping to itself, joined to its neighbors only by the lightest of bonds. But here the separateness is gone. The electrons no longer belong each to its own atom. They belong to all of it at once, flowing freely through the whole crushed mass, a single connected ocean. The matter no longer behaves as many separate things. It behaves as one thing, one vast quantum body, governed throughout by the single deep rule we met. Where once there were countless tiny separate selves, there is now a single shared sea. There is something almost contemplative in that image, and I offer it for you to rest in. The matter of the star has let go of its separateness. The walls between the individuals have come down. The many have become, in a strange and literal way, more like one. The electrons flow together, shared among all, no longer saying this is mine and that is yours, only flowing, only filling the whole, a single connected presence humming quietly. In the dark, there is no struggle in it. There is only a deep unity, a setting down of boundaries, a becoming one. Let us feel too how this substance behaves, for its behavior is as strange as its nature. Because the electrons flow so freely through the whole body, warmth spreads through the degenerate sea with extraordinary swiftness, far faster than through any ordinary material, so that the deep interior of the white dwarf stays at very nearly a single even temperature throughout, a vast warm body of nearly uniform heat. There are no cold spots, no hot spots in the deep interior. The warmth is shared as freely as the electrons, flowing everywhere at once. An even and connected glow filling the whole crushed heart, and the substance resists being squeezed with a fierce and growing stubbornness. Press upon ordinary matter, and it yields a little, then pushes back gently. But press upon this degenerate sea, and it pushes back harder and harder the more you crowd it, because every increase in crowding forces the electrons into higher and faster seats, and they resist that with all the authority of the deep rule. It is matter that has become nearly incompressible, so braced by the exclusion principle that it can bear the weight of a sun without yielding. This is the same stubbornness that lets the spoonful weigh as much as an elephant, the same stubbornness that holds the whole star open against its own gravity. The strange unity of the matter and the strange strength of the matter are one and the same thing, two faces of the single deep rule that governs the whole connected body. So when we say, as the title says, that inside a white dwarf the atoms are crushed beyond recognition, we now know how fully and how literally it is true. We do not mean only that the atoms are squeezed close together. We mean that the very thing that makes an atom has been undone. The private hall is gone, folded shut. The bound electrons are gone. stripped away into a common sea. The boundary between one atom and the next is gone, dissolved. The identity of the element is gone, blurred, into a shared degenerate substance. The atom, that ancient idea of the smallest separate piece of ordinary matter, has been pressed out of existence here and replaced by something with no name in everyday speech, a single quantum body of electrons and bare nuclei, behaving as one connected whole. This is matter as it exists nowhere on Earth, nowhere your hand will ever reach. We can understand it through the deep rules of physics. We can read its signature in the faint light of distant white dwarfs. We can glimpse the faintest echoes of such states in our most careful laboratories. But we cannot hold it, and we cannot make it stay, for it can only exist where gravity grows strong enough to fold the cathedrals shut and crowd the electrons into their forced and shared sea. And that means it can only exist in the still hearts of the dead stars, out in the dark, far from any hand, in the quiet, crushed cores of the embers drifting among the living stars. And so, when you picture a white dwarf now, do not picture a small ball of ordinary stuff. Picture this strange unified substance, this ocean of shared electrons threaded with naked drifting nuclei, this single connected quantum body where the atoms have set down their separateness and their names. Picture matter that has forgotten how to be many and learned, under the patient pressing of gravity, how to be one. It glows faintly in the dark, this strange sea, warm and even throughout, braced open by a quiet rule, holding the weight of a sun in the body of a world, while the old familiar atoms it was, born from rest, crushed beyond recognition in its depths. Breathe slowly, and let that image settle over you like a soft, heavy blanket. The sea of electrons, humming with forced, gentle motion, the bare nuclei drifting like scattered stones, the boundaries dissolved, the separateness given up, the whole crushed heart of the ember resting as a single quiet connected thing. There is something restful in it, this dissolving of boundaries, this becoming one. The matter is not struggling, it has found its balance. It has set down its old shape and settled into a new one, and it holds there, peaceful and unburning in the dark for a very long time. And so, perhaps, can you hear now in the quiet, as the boundaries of the day grow soft and your own restless, separate thoughts begin to settle and merge into the single deepening calm of sleep. Let the sea of the star and the deepening calm of your own mind drift together for a moment, both of them settling, both of them letting their boundaries soften, both of them coming gently to rest. And when you are ready, we will rise again toward the wonders that grow out of this crushed and unified heart, the limits and the crystals and the slow, patient clocks of the dark. Now that we have stood in the crushed heart of the star and seen the degenerate sea, let us gather the most wonderful consequences of all this and let them carry us gently toward rest. Begin with a question the gentle rule seems to invite. If electron degeneracy pressure can hold up the weight of a sun, can it hold up anything, any weight at all, no matter how great? The answer is no, and the reason is one of the most elegant ideas in all of astronomy. The strength of the star comes from its crowded electrons, forced into faster and faster motion as the weight grows. For a while, this works beautifully. More weight, more crowding, faster electrons, harder push, balance restored. But there is a ceiling on speed in this universe, the speed of light, and nothing, not even these crushed and furious electrons, can ever reach it. As the weight climbs and the electrons are driven faster and faster toward that ceiling, they can no longer push back any harder. The pressure stops growing, even as the weight keeps climbing. And so there is a maximum, a heaviest a white dwarf can be. This maximum has a name, and the name carries a quiet human story. It is called the Chandrasekhar limit, after a young man who worked it out. In the year 1930, the physics student of 19 years was sailing from India to England, a long, slow voyage across the sea. And to fill the empty days, he turned the problem over in his mind. He combined the physics of crushed electrons with the rules of motion near the speed of light, and out of that combination fell a number, about 1 4/10 times the mass of our Sunday. Below that weight, the gentle rule holds the star open forever. Above it, nothing made of electrons can save it. There is something moving in the image of a young traveler on a ship finding, in the rolling days at sea, one of the deep limits of nature. The idea was not believed at first. It seemed too strange that nature should set such a sharp edge. But it was true, and it has stood ever since, one of the cleanest results in all of physics, the same for every white dwarf that has ever existed, in every galaxy, across all of time. Let us sit gently with what lies beyond that edge, without alarm, for it is far away and harms no one. Sometimes a white dwarf has a companion star close beside it, and slowly it draws matter from that companion, gaining weight across the ages. As it nears the limit, the long balance grows fragile, and when at last it crosses the boundary, the matter, crushed suddenly past what the electrons can bear, ignites in a single vast release of energy, a brilliant flaring that for a few weeks can shine as bright as a whole galaxy before fading slowly back into the dark. It is not a thing to fear, it is a kind of grand and final brightness, the dead star speaking once more before it is gone. And because these flarings always happen at the same precise weight, they always release very nearly the same light, like identical candles scattered across the cosmos. When you know how bright a candle truly is, you can tell how far away it sits by how faint it appears. So astronomers use these flaring white dwarfs as measuring candles, gauging the vast distances to faraway galaxies. The sharp limit found by a young traveler on a ship has become one of the great rulers with which we measure the size and the age of the universe. But let us return to the peaceful white dwarfs, the great majority that never cross the limit, and follow them into a slower and softer wonder. Let us follow them as they cool. A white dwarf is an ember. It has no fire. It can only give up its stored warmth to the cold of space, slowly, across ages. And as it cools, something quietly extraordinary happens, deep inside it. The bare nuclei, drifting all this while in their ocean of electrons, begin to slow. Warmth, after all, is motion, and as the warmth drains away, the nuclei jostle less and less. And when matter slows enough, it does what cooling matter so often does. It begins to arrange itself into order. It begins to crystallize. Picture water cooling toward ice. While it is warm, the molecules tumble freely, sliding past one another in liquid disorder. But cool it enough, and they lock into a fixed, repeating pattern, the quiet geometry of ice. The same thing happens across unthinkable spans of time in the heart of a cooling white dwarf. The bare nuclei, slowing in their electron sea, settle out of their disorder and lock into a vast repeating lattice, a single enormous crystal growing outward from the center as the star cools. And what is this crystal made of? Carbon, mostly, and oxygen, the ash the star made in its burning. There is a familiar name for orderly crystalline carbon. We call it diamond, and so it is. Sometimes said, with only a little poetic license, that a cooling white dwarf is slowly becoming a diamond, a single crystal the size of a world, a gem of unimaginable mass, glittering in the dark where no eye will ever see it. The image is not perfectly literal, for the crushed, degenerate carbon is not quite the same as the diamond on a ring, but the part of it is true. The star is crystallizing, settling nucleus by nucleus into a vast ordered jewel, the largest and most patient crystal in all of nature. Astronomers have truly found such stars, ancient white dwarfs caught in the slow act of crystallizing, the freezing of their hearts, leaving a signature we can read across the light. Years. And our own sun, when its long life ends and it settles into a white dwarf and cools across the ages, will one day do the same, becoming a slowly crystallizing gem, drifting in the dark, the final quiet form of the star that gave us all our days. There is one last wonder to gather, and it is the gentlest of all, because white dwarfs cool so steadily and so predictably, always fading at the same patient rate. They have become a kind of clock. By reading how cool and how dim a white dwarf has grown, astronomers can tell how long it has been cooling, and so how long ago its parent star died. The coolest, faintest, most ancient white dwarfs we can find tell us the age of the oldest stars, and so they set a floor beneath the age of the universe itself. These dim, cooling embers are among our most trusted timepieces, the slow ticking of their fading, warmth marking out the great ages of the cosmos. And now let us follow that cooling all the way into the deep future, gently, for there is great peace to be found in time so vast that nothing in it is ever rushed. The white dwarf begins its long fade, fierce and brilliant, and across many millions of years it slips from white toward yellow. That alone is longer than there have been creatures on the earth to look up at the sky, and the fading has barely begun. Across many more millions of years it reddens, dimming through orange into the deep ember red of an old coal, and still the road runs on, into billions of years, and then tens of billions, the ember growing, ever cooler and ever dimmer, so slowly that across a whole human lifetime the change would be far too small to measure. The white dwarf does not hurry, it has nowhere to be, and all of time to get there. And here is the most restful fact in all of our journey. The cooling takes so long that not one white dwarf anywhere in the universe has yet finished it, not a single one. The cosmos itself is not old enough. Even the most ancient embers cooling since nearly the dawn of the stars, still hold a little warmth, still glow, however faintly, in the dark. Final cold dark ending that every white dwarf is drifting toward has a name. We call it a black dwarf, a star fully cooled, gone entirely dark, every last whisper of warmth surrendered to the night. But there are no black dwarfs anywhere. There has not yet been enough time for even one to form. They are a thing of the deep future waiting in an age so distant that the present universe, for all its billions of years, is still only the first faint light of morning. Sit with how gentle that is. The embers are still warm, every one of them. The whole long history of the universe has not been enough to let a single dead star grow fully cold. The night ahead is so much longer than the night that has passed. The stars that died at the very beginning are still glowing, even now, still giving up their warmth a little, at a time, in no rush at all, with all the unimaginable ages of the future spread out before them like a calm and endless sea. Let us bring the journey home now, gently, from the far reaches of the cosmos, back to this room, back to the bed, back to your own quiet breathing in the dark. You are made of atoms, and we learned that they are mostly empty, vast halls with tiny specks adrift in them, held together by the faintest leaning of space against space. The same atoms that fill your hand and your heart once filled a star. The carbon in your blood and the carbon crushed into the diamond heart of a dead star are the same. Carbon, all of it forged long ago in the cores of stars that lived and died before the sun was born. You are not a visitor to this universe of stars and embers. You are made of it. When you look up at the dark and feel small, remember that you are also looking at your own distant kin, the stars that made the stuff of you, glowing quietly across the gulf. And like the white dwarf, you are warm, and you are cooling gently toward rest. Feel the warmth of your own body now, held in the bed, sinking slowly into the soft heaviness of sleep. Feel your breath slow, the way the star slows, settling, quieting, letting go of the long day's heat. There is no fire that needs tending in you now. There is nothing that needs to burn. Like the ember held open by its quiet rule, you can simply rest, supported without effort, going nowhere, held. Notice how your body has grown heavier as we have traveled, sinking a little deeper into the bed with each slow breath. There is a kind of gravity in sleep, a gentle pull that gathers you downward into rest, and there is no need to resist it tonight. Let it draw you, the way the star was drawn inward, slowly, softly, with no struggle. Let your thoughts grow as slow and spacious as the cooling of the embers, the crushed atoms, the empty cathedrals, the gentle rule, the diamond in the dark. Let them all dissolve now into the deepening calm, the way the boundaries of the atoms dissolved into a single quiet sea. You do not need to hold them, you only need to rest. You might picture the embers one last time, scattered through the quiet galaxy, far more numerous than the bright living stars they hide among. Each one is resting exactly as you are resting now. Each one is held open by the same gentle rule, settling slowly into the dark in no hurry, asking nothing of anyone. They have finished their long labor of burning. They have nothing left to prove and nothing left to do. And you too, can set down the labor of the day now. You can stop holding yourself open by effort. You can let the quiet rule of your own resting body hold you easily, the way the embers are held, going nowhere, needing nothing, simply at peace in the dark. There is a kind of comfort in living in such a young universe, a universe still warm with the heat of its first fires, where even the oldest dead things have not yet finished their slow goodbye. We are here in the early morning of time, when the embers still glow and the long night is only beginning. And there is comfort too in knowing that the cooling, when it comes, is not a violence but a settling, not a loss but a slow, soft surrender, the gentlest ending in all of nature. A warmth given quietly back to the dark across spans of time too vast for any worry to survive. Let yourself rest inside that vastness for a moment, the way you might rest in the quiet of a great open field at night. All the hurry of the day, all the small urgent things that seem to matter so much, grow soft and distant against a span of time in which a single star takes longer to cool than the whole history of life has yet run. There is room in that vastness for everything to slow down. There is room for your thoughts to spread out and grow quiet. There is room most of all for rest. The same patient rest the embers have found, holding their warmth gently, in no hurry, going nowhere, for ages upon ages. And consider, as you drift, how the same few simple things have shaped this entire journey. A star ran out of fuel. Gravity, which never rests, began to squeeze. The empty halls of the atoms folded shut, and a quiet rule, the refusal of the smallest pieces to share a seat, rose up to catch the falling star and hold it open in the dark. From those few gentle beginnings came everything we have seen, the spoonful that weighs an elephant, the world that holds a sun, the crushed and unified sea where the atoms lost their names, the limit at the edge of strength, the diamond growing slowly in the cold, the patient clock counting down the ages. So much wonder from so little, a fire that went out and a rule that would not let go. We have traveled far. We followed a star to the end of its fire. We fell into the ember and saw its atoms crushed beyond all recognition, dissolved into a single quiet sea. We met the gentle rule that holds the dark stars open and the limit at the edge of all their strength, and the slow growing diamonds in their cooling hearts, and we followed them out into a future so long that the cold, dark ending has not yet arrived for even one of them anywhere in all the universe. There is no part of this you need to carry forward. The facts can drift away like the outer layers of a dying star, softly, leaving only a quiet warmth behind. What remains, when everything else has dissolved, is simply the feeling of being held, the way the ember is held, the way the bed holds you now, the way the vast, patient universe has made room for you to rest in it tonight. You are small, and you are made of ancient things, and you are held. That is all you need to know as the night gathers around you. If you would like to drift on another quiet journey like this one, there will be another, waiting whenever you return, with no hurry and no pressure, simply here for you in the dark. And if sleep comes before the journey ends, that is the gentlest ending of all, and there is nothing you need to do but let it carry you. The embers will go on cooling, whether or not you are awake to watch them, glowing softly in the dark, patient as ever, and they will be there, faint and warm, the next time you look up at the night. But for now, there is nothing left to learn and nothing left to do. So let the last of the day loosen and float away, the way a dying star lets go of its outer light, gently, keeping only the quiet warmth at the center. There is nothing to hold. There is nothing to keep. There is only the soft dark and your slow breath and the faint warm embers glowing far away. The embers are warm, the night is long, you are made of stars. Let your breathing slow, let your body grow heavy, let the warmth hold you. Rest now, sleep well, good night.